So my tutorial today will help you to make a nice graph on R. Sometimes we want to display our data on a box plot, but we also want to understand how our data points are distributed across the box plot, as well as how the distribution of these data point change across time. And to do so, we sometimes struggle because statistical software as SPSS that have GUI will not offer so much flexibility for doing this kind of graph. So in this case, I want to use R, and I'm going to use ggplot2 package in R in order to obtain this nice graph. So now I'll just walk you through this procedure step by step. In my experiment, I have two conditions, and I have two groups of individual, deaf and hearing. My condition in this experiment, which is a task switching, are stay and switch. For in my case, I'm also interested in how some region of interest of the brain, which are the temporal region, respond to this task in the hearing and in the deaf group. So today I am going to show how the right superior temporal cortex respond to this task by showing the data on a box plot which will add data points and line. So in order to achieve the plot, the first thing you have to do is distribute the data on your spreadsheet in a certain way. This way may be different from the way that you use for running a repeated measure ANOVA, for example, or an ANOVA on SPSS. So you have to create a brand new screen spreadsheet, and you gonna have three columns. So the first column is the ID, and my participants are ordered for their ID, and you can see I decided to call the hearing participant 2 and the hearing participant with number below 100 and the deaf participant with number above 100 to help me to understand. But this is just the way in which I organize my spreadsheet. What I want you to notice that for each participant I have two entrants, so two rows. My participant number 2 is present here in the second row and is present here in the 45th row. So because I have two conditions, each participant have to be present twice. If you have 3, 4 and condition, you will have one row for each participant, as many conditions you have. Then we have this name variable called group. In my case, I assigned 1 to the hearing and 2 to the deaf, and as you can see, these repeat for the second time I enter my my participant number 2, and this is a name variable, so it's very important to understand that 1 and 2 do not have any particular meaning, are just labels, so you can call them 0 and 5 or 9 and 8, whatever you like. Is just important that all the participant in group 1 will have in group A will have a certain number, and all the participants in group 2 will have a different number to make sure that your graph will make sense. Third column is condition. So also in this case I have only two conditions, so I'll give one to my control condition, which is called stay in my case, because this is a task switching, and two to my condition of interest, which in my case is called switch, because is called switch since I'm doing a task switching. Again, 1 and 2 are just label, so really you can use whatever number you like. They don't have any kind of meaning. It's just a conventional number. So I just want you to notice that for participant number 2, I have one entrance where group is 1 and condition is 1, which is this row basically represents the activation of participant number 2 in different region of the temporal area during condition number 1. Then participant number 2 is repeated, and in this case the group remains 2 because participant number 2 is a hearing participant, and is or her group doesn't change, but the condition change. So we have condition number 2, which is my case in switching. In my other column, I have the data point for each region of interest. This can be region of interest, score in a test, reaction time, accuracy, whatever you like. Like in my case, I'm using beta value for each condition of interest because this is my interest in this study, but it can be reaction time or accuracy, whatever you like. And for each participant, again, the beta value for the right superior temporal cortex is repeated twice, once for the control condition and once for my condition of interest, which is the switching condition. Again, that's very important in order for the script to work. The data have to be organized in this way. Different organization will not make possible the script to work. So do not just open the same script you use for repeated measure ANOVA or whatever other analysis you are doing, but organize the data properly. So once we have our spreadsheet ready, let's go on R. So on R, I am using this my script is on GitHub, and I'll add a link on in the description of this video. I am using ggplot to library to do this plot. ggplot, you can to install the library, because before running this script you have to install ggplot too. So just Google it and see how to install it. Once you have installed it, just go call the library before your script. So I'll just run this line and I'm calling the library, so the program will load my library. So now let's go row by row to each row of this script. So the first thing I'm doing is telling R that some of my columns are not number, but are not value, are not numerical variable, but they are name variable. And specifically, I'm doing this for ID, for group, and for condition. So what I'm doing here is to tell which spreadsheet to look at. So for the first thing I should do is to load a spreadsheet. So from import dataset from Excel, I'll import my spreadsheet. Now I have my spreadsheet in here, and I'll tell R that ID is a factor. The way in which we do this is define the data set, which is in my case data underscore task switching. Then we have the dollar symbol, and through the dollar symbol we are able to basically select which column of this spreadsheet we like. In my case is ID, and I'll set ID as a factor. So and I repeat, I set ID as factor. So what this row does is basically say that the ID column in the data task switching data set should be set as factor. It should be written as ID in data underscore task switching. So basically I'm just telling the script to treat this ID number as label and not as number. Then we have the second row, which is quite similar to the first one. The only thing I change is that I am saying that this is a factor, and defining this as a factor I can give, so using factor instead of as factor, I can give a name for each level of my variable. I am calling the column called group. I am setting is as a factor, and I'm telling that group has two levels, and my levels are hearing and deaf, where the first label is correspond to the smaller number you enter. So in my case, as I enter 1 and 2, I want 1 to be hearing and 2 to be deaf. The third row does something quite similar, but it does with condition. So it will set the column condition as a factor, and condition as 2 levels, which are stay and switch. So now if I run these 3 row, you can see here that group from 1 became hearing, and from 2 became deaf. Let's do this again for condition. So running condition, you can see that 1 became stay and 2 became switch. So now these are not number anymore. Doing this, you will have the name printed in your plot. So this is very convenient because you just have them printed nicely in your plot. So in row number 9, what I'm going to do is to tell R what it as to a plot. I call my plot TS because there is a task switching, and TS is equal to ggplot, which is the function which makes plot. The first argument of this function is to be the data from the data the data set from where to take data, which is the data underscore task switching, again this one. Then I'm setting the aesthetic. The aesthetic are basically which with this command called AES. The aesthetic are basically what I'm basically telling her what I want to be plotted in my plot. So I want so what I want on the x axis goes as first. What I want to the y axis goes as second. So in my case, I want x to be equal to condition, so to have each condition in each condition on the x-axis, and I want my beta value for right STC to be on my y-axis. So if I run this without adding fill, it will basically just plot all the data from for both the groups in during the two condition for this ROI. I am adding a third argument, which is the fill, which is basically the color of my boxes, and I'm telling R that I want my two group to be color in different color, so automatically R will create the separate boxes for my two groups. So these until now we didn't tell really to R whether we wanted to have a box plotted, line plot, box plots, leg plot, or dot plot. We didn't tell it. We just tell R that we wanted this plot called TS, and what are the argument of TS. So now I just run this line, and as you can see, TS is created, but there is not yet a plot from here. I delete this because this is my previous plot, so I don't want I just want to show you that running this doesn't create any plot. It's just tell R this is what I want to be plotted. So what we do next is basically build on this plot and just design it. So I want these so how we do this is to call TS again, and then to add other elements to the plot. So I call TS, and I'm here I am telling that I want R to design a box plot from TS, and here I am just telling R that I want my outlier be color red, but this is just cosmetical. You can put whatever you want. Then I add a plus sign, and I am telling R that I want to add a point to this box plot. So in this case, I'm telling her that for each data point, I want a point to be drawn on my box plot. Then I am adding a title, and my title is task switching right superior temporal cortex. You of course add the title that you prefer depending by what your variable are. I am manually setting using the color. In my case, I am using turquoise for hearing and coral for deaf, but feel free to use whatever color you like. If you are interested in different color on the web page of ggplot, there are tons of color, and you can just see what are the label and replace this geo label here with your favorite color. So far what we have is a box plot with some dot plot, but now we want to add a line plot. So we want to see how our beta value of our deaf and hearing participant change during the task and during the task condition. So in order for doing that, I define another plot that is a line plot, and I'll call it with this function called geom underscore line, and I define an aesthetic argument, which is ID. So in here I am telling her that this line should connect data point who have the same ID. Okay, I hope it makes sense. Then these are just cosmetic, and it's basically defining some fonts and argument for the title and for the axis label. You can explore these as to change these argument font and size on ggplot web page, because it's well explained. I am adding a legend, and the legend will define my color as two different groups. And with theme, I am just defining which theme I want to use with on my plot, and there are several themes. Like you can basically have your plot like white, gray, dark, with different fonts, and again on the ggplot 2 page you will find a list of different themes and a description how they look like. The last argument is basically the facet. So because I have two different groups, what I want to do is to separate my groups into different boxes, so that will help visualization and will make our graph look nicer. So I add this argument facet underscore grid, and I'll tell that I want these boxes to be divided by my variable call group. The last note is you always see a plus here, because this is basically the same function. So if you don't put a plus, R will ignore the argument that are not connected by a plus. You will not understand that you want all this bit to be added to your graph. So now let's just run it, and how you can see, we obtained this nice graph, and you can see it's shown very nicely that our two groups have different trends. A more condition, since the deaf group seem to increase, activation in the temporal area during my switch condition compared to the stay condition, and the same thing, it doesn't occur in the in the hearing group. I hope you enjoyed this, and please feel free to email me and to to ask any question or clarification you want. I just want to again remind you that the script to do this graph is on GitHub. I'll link it to the description of this video, and you have to just change the name of your variable to run this script. The very last bit I want to show you is that this graph can be saved as an image. You can save it as PDF, or you can save as an image, and you say I just selected my directory. You can name it whatever you want. So for example, task switching right stc. And another very useful things is that you can change the format to be different formats. So you can use like JPEG, PNG, or whatever format you want. I use EPS because EPS allow you to open the graph in different programs, for example Illustrator, and change things. So if for example you want to change the font or I don't know, make all the graph on the same size or add more graph in a single figure, you can do this by Illustrator if you say save this on EPS. In any case, you can also just save in JPEG or whatever other format, and just copy and paste on your report or your paper or whatever you like. Thanks again for listening, and I hope you enjoyed the tutorial, and let me know if you have any questions.